This is a video submission for the National Science and Engineering Competition 2015. My project deals with graph theory, a branch of mathematics which has many applications in computer science. It is titled Visually Pleasing Graph Representation Using GraphDraw. I completed it during a Nuffield research placement at the University of Glasgow during the summer. Hi, I'm Sharan Maya and I'm from the Glasgow Academy, and my project concerns the representation of graphs in a visually pleasing way using a program called GraphDraw. So in graph theory, which is a branch of discrete mathematics, graphs are used to show pairwise relations between objects. A graph is defined as a set of vertices, commonly drawn as circles, with some edges drawn as lines between them. And they're used to model various different situations and networks. For example, the vertices could represent airports, and the edges could show flights between them. Now, the Department of Computer Science at the University of Glasgow was researching the properties of graphs of girth 5. That is, graphs which include no triangles and no squares. They were specifically looking at graphs with this property with vertices in the range 20 to 32. Their program GraphDraw can be used to draw graphs using symmetry by allowing the user, in this case me, to input the adjacency matrix as well as one of the generators from the automorphism group. So I was using this piece of software to create the most aesthetically pleasing representation of each of the graphs I mentioned before. But why is it important that they were visually pleasing? Well, research suggests that a visually pleasing representation of a graph can make the job of analysing it and interpreting its structure much easier. For example, the two graphs shown here are exactly the same. However, this one has been drawn using symmetry, among other factors, to make it much easier on the eyes than this representation. Some of the other factors which could be taken into account when drawing a visually pleasing graph include arranging the vertices on a known geometrical shape, such as the circle, or minimizing the number of edge crossings, as this makes it easier to discern edges from each other. Now, the program GraphDraw is actually quite new, and I was also given the task of evaluating it. Some of my suggestions for improvements included some basic functions to allow the user to manipulate the current graph being drawn. For example, the ability to move or remove a vertex, or even to rotate the entire graph. One particular function which I thought would be especially useful would be the ability to save a vector-based image of a graph. See, the main purpose of drawing these graphs was to include them in some textual format. A research paper, for example. Saving a bitmap image of a graph means the computer stores it as an array of pixels. And I'm sure everyone is familiar with the problem of trying to resize an image and having it appear really blurry and pixelated. A vector image, on the other hand, is saved by storing the key shapes, and this means it can be resized without any loss of quality. So I edited the source code of the program to include a button to do this. So in conclusion, I was able to create visually pleasing representations of all the graphs of girth 5 with vertices between 20 and 32. These images will be included in a larger research project being done by the department. The evaluation of their program GraphDraw suggests that it still needs some improvement in addition to the ones included in this project. But hopefully, GraphDraw can become a much more user-friendly method of representing graphs in the future. The research of these graphs is still ongoing at the University of Glasgow. Thank you.